What's up, comp sci students? Today we're going to learn about the array implementation of queues using generics in Java. So a little bit of conceptual understanding here. We have a full video dedicated to that. I recommend you check that out. We'll just do a little bit right now. So imagine this is your typical lunch line, and this is the front of the queue, and the queue has, say, 4 slots. And so what we would say is, this is the front of the queue. And then when the queue is empty, this front would also be the rear of the queue. But as people come in, say another person comes in, this would be the rear, then another person comes, so this would be the rear, and then another person comes, so this would be the rear. And if another person try to come, the queue is full, so no one else can come. And so we would say the queue is full. So let's turn over to our coding environment, and I'm going to make a class called queue. Now, let's start off with these important variables that make up a queue. First, we're going to make a private integer front and rear. And the reason I'm going to call them integers, or I'm going to make them data type integer, is because we're going to want to assign them the value null. Now, because we're using generics, we're going to do this data type up here. And now we're going to make the private int max size and queue size. So these can be ints because they are actually numbers that we are going to assign. These the front and rear, we want them to be integers because we want to assign them the value null. If you were doing an int implementation only, you may run into some issues where you actually want to push the value 0 or -1, say, but then to erase a value in the front or rear, you will also assign the value 0. So you might run into some issues there. Better to be safe and assign the value null, which you know will be an empty element in the queue. Cool. Finally, we're going to make the queue itself as an array. So note that we're using object because we're doing any data type. Generics means that you can store any data type within the queue. So here we can have, we can have an int, so 10. Then we can have we could have a float or double, so say like 3.2. And we can have a string. That's possible. Or as we saw in the stacks video, a surprise, we can have emojis as strings. So this T up here, or using generics in general, means that you can store any data type in the data structure. Awesome. So we're going to give us some space over here, and we're going to implement the queue itself. So when we start off and make a queue, the first thing we're going to want to do is tell the code or the program what maximum size we want the queue to be. So we're going to set this size to max size. Then we're going to create the queue. Again, object, so that it can be any data type. Max size. This notation basically creates the array with this number of elements, or max size, number of slots, better said. Then we're going to set the queue size equal to 0. Queue size is the size of the queue. This will facilitate later the queue size method to see how big a queue is. It's going to be the easiest. This is going to be the easiest way to do that because we can just keep track of how we're unqueuing or adding values or dequeuing, removing values from the queue. So then we're going to set front equal to 0 and rear, we're going to set it equal to -1. The reason we're going to do that is because we want to keep track of the accurate value of the rear. So every time we're unqueuing a new value, we're going to add 1 to the rear. So say here, oops, oh no, I didn't know where to do that. over here. When the rear equals the front, it is so that we can append or add our value to there. Before that, however, the rear just doesn't exist. There's just a front. And every time we're gonna onQ a new value, we're gonna want to move the rear to the next. So then every time we're performing the onQ method, we're gonna be adding 1 to the rear. And these slots correspond to the indices, make that better, to the indices of the Q array. Excellent. So that's the reason we're starting rear with -1, so that now every time we're onQing a value, the first value we onQ, it goes to index 0. If we started rear at 0, it would go to 1. Cool. So that's the initialization of all our variables in Q. Now we're going to start with what we just talked about, which is the onQ method. So public Boolean onQ, and we want data type anything value. And what this is going to do is we are going to onQ value into Q. Now, how this works the following way. Let's actually get rid of all this. We've kind of already gone over it, but we're going to do it now for real. Oops. Say first value, we want to onQ the value 8. So rear from -1 is going to be added to, well, it's going to be added 1, so it becomes 0, and then we onQ the value 8. Then we want to onQ a crazy number with many decimals, okay? For that, we're going to have to, let's do it properly, cool. So that was 10. To onQ a new value, we're going to want to increase rear and then populate that slot with a crazy decimal. And then we're going to want to increase rear by 1 again to push or onQ a new value and say we want the string hello. So you get the idea. The main issue or task is to increase the rear and then onQ the value you want. What happens, however, when you've onQ'd a ton of values and let's do a happy face over here. This is a rear now. What happens if you want to onQ a new value? You can't, because this is the end of the queue. So you're going to have to tell the user, hey, you can't onQ anything else because the queue is full. So we're going to have to check for that in our onQ method over here. So what we're first going to do is we're going to increase rear by 1. So what we're going to do is rear plus 1 mod max size. And the reason we're doing mod max size, we're going to go over it more in depth in the dequeue method, but it's because when we start dequeuing, we're not going to want to move all the elements in the array to the front. Rather, we're going to want to move the arrow of the front to the new front. And so we're going to have an empty slot where there used to be a front, but now it's going to become the new rear. So that when front then becomes 2.78, 10 is gone, we push or onQ a new value, the rear becomes 0, front becomes 1. But for rear to become 0, it has to have added 1 to 3 and done the modulus max size. It's very complicated. Don't worry, we're going to go over it very shortly. Just trust me in this one. Cool. So We do that, and then if the queue is full, and the condition for that is if the rear equals the front, yes, the queue will equal the front, or the rear will equal the front, because if we're trying to unqueue a new value, rear is going to be added 1 over here. When you added 1, 3 becomes 4, mod max size becomes 0. No, I did not want that. Cool. Rear is going to become 0, and both front and rear are going to point to the same number. So the condition for the queue to be full is that rear is equal to the front, and the queue index front actually has a value. In other words, it's not null. What we're going to do then, what we're going to want to do then is we're going to want to print a message saying queue full, can't add anything, and then return false. The reason I'm making the onQueue method return a Boolean is so that when coding, we can actually get output on whether the method was able to push or onQueue a value or not. So if the queue is full, we return false, we can't onQueue anything. Next, we actually have to onQueue stuff. So we're going to do set the value at the rear position of the queue, and then increase the size of the queue. And again, this is just to keep track of our size of the queue, not really important. And then we're going to return true. Awesome. We're gonna, yes, this should be working. I don't know why. Oh, well. Cool. The next value we're going to want, the next method we want to create is the dequeue method. And this is when things start to get very interesting. So public, we want to return the value we're dequeuing. So no argument for this one. What is going to happen is we are going to, here, let's get another color. Green. Cool. What's going to happen is we're going to dequeue the front. In queues, queues follow the FIFO order of operation, meaning first in, first out. So 10, which was our first number, is going to be escorted out, and then we're going to get rid of this. And then instead of moving all these numbers over in the array, which now would be okay, but imagine if you have a queue of 1,000, 10,000 elements, the computing time would be tremendous. Therefore, because it's all invented, computer's going slow. Okay, come on, come on. Okay, we're back. Because everything is invented, let's just change where the front points to. That might be a little counterintuitive, but it's going to save us a lot of time. So now the new front is index number 1. So we have a free value over here at 0. And now if we actually want to onqueue a new element or value, all we have to do is add 1 to the rear and make it mod max size. Cool. So, oh, why is this not working? Anyway, let's go back here. That's lagging a bit. Yeah, so actually I want to show you conceptually on the whiteboard much more helpful. If we want to onqueue a new value, all we have to do is increase rear by 1, which would be 3 plus 1 equals 4. Do the mod max size and we'll bring it back to 0. We'd populate this with some value, and then this would become the rear. But the queue would actually read this, 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 then that. Okay. So anyway, let's keep going with the. Ooh, it's going very slow today. Let's keep going with the dequeue method. Let's see if this is going. Nope. Sorry about that. Well, Whiteboard doesn't want to follow my instructions today. But now it does. Anyway, that won't work. Okay. When we dequeue, we want to check if the queue is empty, because if it's empty, you can't dequeue anything. So what we're going to do is first check for that condition. For the condition for that the queue is empty is that the front is equal to the rear, and at the same time, the value at index front is null. In other words, there is no value at the front or the rear because they would point to the same place. So if front is equal to the rear, and we're going to add this other condition for the beginning, that rear is equal to -1, because that's only going to happen in the beginning. Here we go. Q front has an actual value. Cool stuff. Then we're going to want to tell the user the queue is empty. Queue empty. Oh, we got to make that a string. And then we're going to want to return null. Now, for the actual dequeue method, what's going to happen is we want to return the value. So T, which is any data type value, is equal to Q front, because we are retrieving the element from the front. Now, watch how we have a red underline. What's it asking? It's saying, you're giving me back an object, but we want data type T, which is any data type. So what does any good computer scientist do? We just cast it into data type T and problem solved. So what we're going to do is, let's see if the whiteboard works now. Well, there's no undo function, but you can do that. Cool. So let's imagine our, our queue was like before. The front is at the actual visual front. The rear is at the actual rear. So this was the front. This is the rear. Cool. So what we did was DQ10, and now change front. Oh, starting again. Anyway, change front to the next value. And also erase this value that used to be at the front. Okay, so let's do that. We retrieve the value at the front. What we're going to do then is we're going to delete the value from the front. So front equals null. Then front is going to equal itself added 1. And for the same reason as before, we're going to add a modulus max size in case you keep going and popping and then adding at the rear and then you go back in the queue. I mean, that's a pretty complex queue, but again, we want to make sure we cover all cases as much as possible. We're going to want to keep track that the size is decreasing, and then we want to return the value we are dequeuing. Cool. So that is a dequeue method. Now, another very useful function is one that tells you directly, without doing anything, just returns to you the value that's at the front of the queue. So that is called the front method because it just tells you what's at the front. And all that's going to do is first we're going to check if the queue is empty and we copy paste it. But remember, copy pasting is very dangerous. Be wary. This is safe because we're just checking for the condition that the queue is empty, and that condition will be the same for all. So all we're going to do after is return. Again, cast it with any data type, queue, the value at the front of the queue. Awesome. Another function of great use, I mean, by the way, all these functions are now all that you need for a queue, because a queue, all that a queue is unqueuing and dequeuing, unqueuing and dequeuing. That's all you need for a queue, really. So now we're adding functions that are, or make the usage of queues more useful or easy to work with. So another function that's pretty useful and one that we've been already kind of doing is the size method. And in Java, functions and methods are interchangeable. So all we want to do is return queue size. That is all. We're returning an int. And because we've been keeping track of every time the size increases in the onQueue method and every time the size decreases in the dequeue method, all we have to do is return this variable queue size that we're keeping track of. Alrighty, and the last method that's very useful to have, public string, some extra indent, public string to string. We're going to, this is just to, again, print the queue. Let's see if my whiteboard allows me to explain dequeue a little bit better. Honestly, let's just erase it all and start from the beginning. That work? Much clearer. Cool. So again, this was your lunch line. Voila. I trust it's just all gonna draw. I did draw it all. Let's see what happens. Yay, cool. So let's put that in here. 10, 2.8, hello. Happy face. We're gonna try the happy face again as we did in the stacks video. So there's gonna be the front. There's gonna be a rear. When we dequeue, what we're gonna do is we're going to get this value 10, we're gonna store it so we can return it. Oop. So yeah, we're gonna delete it so the queue now becomes useful. And then we're also gonna change the position of the front. This is gonna become the new front. And so what happens if we onqueue a new value? Well, the rear would be rear plus 1 mod max size. So the rear would point over here. We can get rid of this value because we dequeued it and we did whatever we wanted with it. And then say we onqueue value 9. Cool. Now this is obviously a bit counterintuitive because this is index 0, this is index 1, this is index 2, and this is index 3. And so now when we dequeue, what's going to happen is we're going to get this value out of the way. We're going to erase it and change the position of the front. And now index 1 is free to onqueue a new value, say 8, when the rear will move over. And then we keep going like this. Okay, awesome. So this is what happens. The queue basically moves around, and all it is a rearrangement of arrows. You should also probably look at the pointers and objects blog post, which gives the fundament of this. Cool. So let's go back to our toString, or apparent according to this toString. toString. Cool. And what we're going to do is print the queue. And for that, we're going to assign string s going to be equal to that, just to initialize it. And then we're going to check again if the queue is empty, because then we don't need to print anything. We're just going to return queue empty for the user. Again, remember, copy pasting is dangerous, but as long as you do it carefully, and as long as you fix it after you've pasted, yeah, we're talking about computer science, not anything outside of computer science, then you're fine. And then what we want to do is traverse front to rear and print the elements, because fundamentally we started the front, and all we want to do then is go to the next one, then go to the next one until you get to the rear. So what are we here for that? You guessed it, a for loop. So for int I equals front, and this is when things start getting interesting. I is less than front plus max size. I plus plus. And then you'll be like, why on earth should we go beyond the max size? Because front plus max size is most commonly going to be more than the allowed max size. And the reason for that is due to how for loops work. So the I will start at the front index, and it's going to keep going. But in this example we have right here, for instance, it's going to start at index 2, and then it's going to keep going. And then it's going to keep going, but you can't go above index 4. So it's obviously going to return an error saying, hey, you have no index 4. What we want to do is, when it goes over to 4, we want to do a mod that goes down or goes back. This thing draws whenever it wants, and then we're going to want to go back to here. So as we iterate over the queue, we're going to 2 to 3, and then 3 to 4, but we want 4 to take us all the way back to 0. However, the for loop is not that smart, and it's going to say I starts at 2, and it's going to go to values that have to be greater than 2. Because ideally, what we want to tell the for loop is start at 2, end at 1. But that doesn't really make much sense to the for loop. So what we're going to do is say start at 2, end at 6, and then fix 6 when we're accessing the array. Let me show you. We're going to concatenate to the string we just created and say we're going to access the queue element at I mod max size. So this is the reason. We have to keep going in the for loop. I needs to keep increasing until the limit. Obviously, those new indices don't exist in the queue. So when we're accessing I in the queue, we're going to do a mod max size so that when it becomes 4, it takes it over to 0. When it becomes 5, it takes it over to 1, and then it ends. And that's how we print a stack. We have to return S, And that is all for implementing a stack with arrays using generic. So now we're going to test the code because, again, testing is one of the most important things in computer science. Testing is sweet. So, very sweet. We're going to create Q, Q equals new Q with size 4, like we have in this example. We're gonna first want to sout or print Q to see if we get a Q empty message. Let's see if we get that. Excellent. This means that our toString method is currently working, or at least the condition for Q being empty. Again, remember, rear is currently -1, right? That was why we added here. Or rear equals -1 for this specific case, because we started -1, and every time we're going to onQ a new value, rear is going to increase by 1. So let's now start onQing. onQ, and let's do 10. Then we're going to onQ, Q to onQ, whoops. One of these crazy decimals. Awesome. And now how about we test the size function? Should give us 2, and again, should be pretty accurate because we've been keeping track of it throughout the Q and DQ methods. So let's do cite there, size. Let's actually print out the Q now and see what happens. So we've onQ'd 2. Oh, look, our DQ, our toString method is going to want a space in between so that everything is much neater. Cool. That looks much better. Awesome. So what do? We onQ'd 10 and this ugly number, not ugly, but big, doesn't mean anything. And then we printed the size. Oh, wait, did we call it size? We did call it size. Where is that printed? Oh, 2. Because these don't return anything. So that is 2, and then we're printing out the Q, which is exactly what we have inputted. Let's also sout, in other words, print whether this is returning true or false. Excellent. So our Boolean is working great. Let's keep testing. Now let's keep onQing stuff. So let's do Qs are fun. And then Q onQ an emoji. I was struck to celebration. In celebration that we have coded Qs. I was struck when this is possible. You can see my discovery in the stacks video that you can actually print or store emojis in these data structures because you can use generics, and generics allows you to store any data type. That's why generics are so awesome. Awesome. So let's onQ everything, and we should get the exact same output. And now this is where the fun starts. Let's do a test of size. Oops, Q.size. So we're going to get 4, and now let's try to onQ a new value, which will not pass because we've already reached the max size. So in theory, we should get a Q full. Yes, excellent. And look, our size also worked. Awesome. So that condition for Q being full in the onQ method is working right over here. And that is because the rear was added 1 and it matches with the front, and the front element has a value. Great. Let's now start DQing. this is where the fun starts, because we're going to dequeue the first item, which will be 10. And then we're going to print out a dequeue of the second number in the queue, which is that crazy decimal. And then we're going to, how about we test, well, let's test this. So we left a queue full, then we dequeued 10, and then we dequeued the decimal, and we're printing it out. That's why this method, the dequeue method, returning the value is so useful, so that you can return and see what you're actually dequeuing and doing. Cool. So now let's test the front method. So q.front should return us queues are fun, which they are. Oh, wait, but we need to print it. Do that again. Awesome. What if we onqueue a new value? Let's do a another decimal. These decimals are fun, as long as you don't put letters. Ooh, this is a big one. Great example. And now we're gonna test out the front again to see if front actually keeps track. onqueue. Seems to be a mistake over here. Is there? Onqueuing. Let's print out Q to see what's going on. So Qs are fun. This. Huh, interesting. So this is why testing is so important. Oh, actually, never mind. Never mind. It's true. I was thinking of stack. Sorry, everything is working correctly. That's funny. The front here is always going to be Qs are fun until we dequeue it. Unqueuing this will not make it the front. Ooh, seems like the decimals do not work. Well, these are always tricky values. Anyway, that was a lapsus. Everything is working correctly. Woo, thank goodness. So the q.front will still return Qs are fun because that is the front of the queue. Good for you if you caught that. And then let's do a test for size. And then let's dequeue our Qs are fun and end with our celebration phase. Let's see if that works. Yippee! Celebration! Hey, you learned how to code queues with arrays using generics. You deserve a chocolate. Awesome. So that is all about, that is all for coding queues with arrays. Take one last look. This code will also be in this exact same page you're watching this video from. So this is the code. I hope you learned something. I hope you keep coding queues or use them eventually to store data. And as always, keep coding. See you next time.